everybody here. Be nice.
Can you get the door back?
Yeah. Alright. And I'll kind of introduce things, and I'll let you introduce any of your other panelists that are here, or let them introduce themselves too. But alright, thanks for coming everybody to another STEM Academy capstone presentation. We got Josh here doing a accumulation of 3 years of solid work in the STEM Academy through coursework and community engagement, and now his capstone. Thanks for being panelists, those that are here. I have a sheet for you to kind of write some feedback on. The front page is just the purpose of the academy itself. And then the project description. Josh has an option between 2 capstone project presentation types. So the first one is either a showcase to solve a real world problem with increasing awareness. The second one is to actually like perform a service, create something, build something. So you can kind of determine which one of those that is. And on the back is just kind of a spot for you to jot down some notes on the presentation itself, as well as the content involved. And then afterwards, we'll just do kind of a Q&A with Josh. Luckily, he's used to that with our STEM projects already, where he's used to Q&As, but if you could just maybe jot down 2 or 3 questions, then we'll kind of go around and have people kind of ask away. But Josh, I'll kind of let you introduce yourself and what you're going to be doing here. So thanks for coming, everybody.
So I'm Josh Hua, and first of all, thank you all for coming here today and taking time out of your day to attend this presentation. It really means a lot. So starting off, I want to first introduce a bit about my background with STEM. So one of the earliest activities that I've taken part in was the first LEGO League, which was a really cool experience for me because it was one of my first introductions to engineering and coding through robotics. And also, besides that, it also taught me how to apply engineering to real-world concepts. Like 1 year, our team designed but didn't make some kind of solar water purifier. And besides robotics, I also took part in a number of activities related to STEM for the Honors Academy. And these included the Junior Science and Humanities Symposium, which is a really cool gathering of a bunch of really talented and intelligent students perform all these projects, and similar to this. And it's really impressive to see it because you have a range, like you have people growing meat in test tubes, people trying to redesign the pipe system in their towns, and you have like kids who are doing actual like new research into certain types of enzymes. So it was a really enlightening, inspiring, but also humbling experience because you see that there are just some really talented people out there. I also helped with some app design research for River Edge, where I as a teen kind of gave my input into what I would like to see in a River Edge app. I also interviewed an engineer, Jared Fider, who's the president of Energetics, and it was really an interesting experience to get to talk to him and find out what it was like to work as an engineer and his story about how he got to where he is. So, with that out of the way, let's get to the issue, which is this gap right here, the cistern. And the issue with it is that we have this massive hole right in front of our basement back door, and there's not really a good way around it, since you can kind of see here, there's a really steep hill, and we have like these piles of cinder blocks that are blocking it. So the only way to get to the door is to cross the cistern. And right now what we have is just a pile of rotting planks and boards. It's not the best way to get across. And my family has been wanting to replace it for the past 10 plus years. And I thought it would be a good time to fulfill that desire. So, to do it, I decided to follow the engineering design process. And this graphic might look a bit familiar because I stole it from Mr. B. So,
Good spot to start.
yeah, I followed the 7 steps, which are asking and identifying the needs the project must fulfill. I researched the problem, came up with some potential solutions, decided on one, and explored it further. I created the prototype, I tested it, and then I looked at ways that I could improve it. So, for the first step, I identified the needs that it must fulfill. So, it needs to be able to bridge this 3-foot 10-inch gap. But it also has to be narrow enough. You can't take the whole cistern, because we have to be able to fit our sump pump down there and be able to consistently take it in and out, because if we don't, the basement will flood when it rains really harder when snow starts to melt in the spring, and we do not want that. Additionally, it must be able to support the weight of all of our family members, and it must also be cost efficient, because there's not really a point in creating a bridge yourself. I mean, except for the experience, but there's not. But if it costs more than just buy one pre-made, there's not really much of a point in it. So with those constraints in mind, I decided to research further into the problem, and just in civil engineering in general, so that I could get a little bit more background. So I did this by reading the book, The 99% Invisible City, which is this book all about cities and the parts that they make them up. Specifically, the most mundane and like ones that people probably don't even notice. And it's really fascinating to see all the work that's put into them. Like, if you think about manhole covers, you might not have ever thought about why they're round. Well, it's so that no matter which way you turn the circle, it won't be able to fall into the hole that it's into. Like, with a rectangle or a triangle, if you would turn it a certain way, it wouldn't be able to slip in, and then you could just have this gap, or you could fall down and hit someone on the head who's down there. And it would just be an overall hazard. And another thing that I learned from this is, the dotted lines on highways are spaced specifically at a distance so that when you're driving down the highway, at 70 miles an hour, it feels like you're going slower because they're spaced out at a further distance than you'd expect. So that way it feels similar to when you're driving on a slower road. And it creates the illusion that you're not going as fast and you can be a little bit calmer. And I just found this really fascinating that even something as simple as just the lines on the highway could have that much work and forethought put into them. I also decided to research some bridges in general. Like, I remember I looked at the Mackinac Island Bridge, and even though it's on a much different scale than mine, it doesn't directly translate to a garden bridge kind of design, but I still was able to gain some important knowledge from it. So, to get a couple of designs, I decided to look, Google garden bridge and look at images for inspiration. And these are a couple of designs that I like. So I looked further into them and tried to decide which type of style to pick. And the one I decided to go with was an arched bridge. The main reason for this was my mother, since she was the one who had been wanting the bridge for the longest time, and she thought this one looked the nicest. And that doesn't even carry a whole lot of weight, especially considering that she was the one who was most likely going to be funding the project. So, yeah. Having decided that, I put more research into it. So I watched a couple of YouTube videos, like this one here was especially helpful to be able to understand how to make one of these and how the proper way would be to construct it. And then I decided to alter designs a bit so that they would fit my strengths. So I used SketchUp, the 3D modeling software, and modeled my own bridge as a guide. So, with the design, there's still a couple of other aspects to, figure out. And one of them is the type of wood. So I considered cedar wood as well as pine wood, but ultimately decided on pine wood because it is the cheapest wood that was readily available, but it's still durable enough and strong enough. So I wanted to make sure that before I started building that it would mathematically and physically work out and that the wood would be strong enough. So I tried to calculate the strength that could bear with tensile strength and compressive strength. So to calculate the amount of weight compared with tensile strength, I took the tensile strength, 40 times 10 to the 6 newtons per meter squared, and then set that equal to the force exerted on it over the cross-sectional area, which follows the formula that you use to calculate tensile strength. And then through some algebra, I found the amount of force that it would take to break it, and then from that, I was able to find the amount of weight that would be needed in the kilograms, then change that to pounds. And then because compressive strength uses a similar formula, I was able to do that pretty similarly. But to me, these numbers seemed a bit too big, and I was kind of suspicious that I had messed up along the way. So I asked Mr. Schmidt for his info, and with his help, I was able to see that they were a bit more reasonable. with some experiments, like, if you can call them that. If you can call getting all the guys in physics class to pull on two ends of a piece of wood and see if it will break, and it didn't. So with that and some other calculations, I was able to deduce that the calculations were within a reasonable distance of the ballpark. And yeah, a very flattering picture, me hanging from a tree. So as you can see, wood is strong enough to support weight, and I was convinced. Let's say that. So, with all that said and done, it was time to create a prototype, which I started to do by preparing the lumber. So I cut it into the sizes needed that I referenced through my SketchUp design. I made the arches using a paper cutout pattern so that that was half. Then I flipped it over after tracing it so that it would be pretty much symmetrical. Then after that, I sawed it, and if you can see kind of here, they aren't exactly the straightest or most beautiful curves, but I was able to fix it and make them mostly even through a lot of sanding. So what was next was to attach the beams. So I screwed 3 beams onto the outside, then set for each side, then set it upright, and screwed in the 3 planks that were connected, and then attached the other side to it. And with the main frame of the bridge done, I was ready to attach the planks along the side. So with that, the bridge was pretty much complete, except I added some rope to keep it, allow easier crossing. So the bridge worked. It was able to support the weight of all my family members, including the heaviest, my dad, whose weight I will leave confidential. Yes, it worked. And as you can see, the tube leads for the sump pump, and it fits. And if there is some trouble getting it out, the bridge is wide enough that we can just push it a bit to the side so we can get it out. And it works. But there are some issues. For example, some of the planks along the curved parts, when you're walking along the bridge, there's a little bit of bounce and give, so that could be an issue. That could be solved by getting a thicker plank, a little bit thicker wood, I think would be the best solution. But especially, this could be a hazard when you consider decay. And cisterns are a pretty wet place, so the decay is going to happen a lot faster and it'll start to rot. And in order to prevent that, the next steps would probably be to protect the wood using some kind of lacquer or varnish, and that's where I'm probably going to go next. So overall, this project was, even though it was pretty simple, it taught me a great deal about engineering, about following the process and planning out, because normally I just kind of wing things as I go. But this was a good change of pace that really taught me about how to think about things more critically and plan more forethought. And overall, it was just a really great experience about my first actual hands-on introduction to engineering. So, thank you. Any questions?
Nice. Okay, good job, Josh. Yeah, I guess we'll now go to any questions or anything you need to jot down, but we can either go in order or somebody can just kind of fire away when they feel like they have something they'd like to share. Write down a few things here. I'll fire away first because I'm ready to go. So I had a few questions here, so I know which one I want to start with. So you want to make, so let's say instead of doing it yourself, you want somebody else to come in and do this exact same project.
Yes.
I'm curious of how similar, who would actually do something like this, and cost comparisons or how it would be handled. Did you look into what would happen if you ever look into hiring this out compared to what you did and kind of the main difference?
But buying a pre-built garden bridge from Home Depot or Menards.
Okay.
That's what the comparisons were for.
Okay. what was the cost comparison? Did you come out all right in the net on?
Pretty much, I think. A little bit, maybe a little bit cheaper.
I guess I'm looking at the. You're looking at the bridges too. What did you find here, Mrs. Hua?
I'd say to buy a kit, I want to say it was around $400.
Okay.
And Josh's project was about $148 for supplies.
Okay, got it.
Plus, it's custom sized.
That's right. Custom built. Yep.
I mean, you can't always get exactly the width or the
No,
length.
Right.
no. So I would say quite a cost savings, although I don't know exactly what their materials would have
Right.
been made out. So there's a lot of factors there.
Mm, Okay.
Being pine probably helps out with that a lot.
I
Definitely.
was just gonna say. Yeah.
Speaking of which, I have one, if Mr. B is done.
No. Go ahead.
You mentioned you were pondering over pine as opposed to cedar.
Yes.
Were those the only two choices you had in mind? And if so, why so? And if not, your other thoughts on possibilities? For example, pressure treated lumber would be a classic outdoor thing, or oak is another classic for flooring. Did you look into other options there?
I did, but those were the two main lumber types that came up due to cost.
Okay.
So that is one of the
Others would
primary
be
factors.
prohibitively expensive, is what you're saying.
So you did?
Did you have any issues with supplies? That is, did you look at some things and they go, oh, we're not stock, we don't have any of that in stock or whatever, with some of the,
Not really any of that, but it was kind of a hassle to go through all the wood and try to find ones that were straight. We spent a good half hour.
age old problem there.
How long did the construction process take?
It really didn't take that long. Maybe like, what, 4 hours in total
That's impressive.
after all the preparation and stuff. Maybe
Mhm.
like 6 hours, including like cutting all the wood. Surprisingly short.
Fire away again. Here, give her a shot. So like, I love this as a fix for you, and this is what you and I had talked about, like when we first presented this project. I love this fix. I love how it's, it's gonna make. I'm feeling almost like a family portrait, along the garden bridge would be perfect. But like how?
Maybe wait till somebody's blooming next to it.
Yeah. You mean the March isn't pretty in Wisconsin? So I'm gonna ask this too, of like, so Josh, somebody that's looking at this, like, my question is the now what of like taking this and like where does this apply now? Like how can we take what you've done and like where in society does this fall? Like how can we take what you did and use it elsewhere? Like what's your first initial thought of like, this helped me. Now how can I use this to help others? Is this just like you're a cistern business, or like or is this just kind of like in general engineering thinking and problem solving? I mean, what are your kind of thoughts on where this can be used next?
Kind of a more selfish application. Like because through what I learned from this, I can use this knowledge to help others. But besides that, I could like document my progress, my plans and stuff, put it on the internet, like upload a video to YouTube, and maybe someone else who wants to prospectively build a bridge similar to this could use it.
Got it. So like building it something similar to this, because like my other one was like, let's say somebody says, well, I'm looking to build a bridge about 4 times as big as this. Can I just use a ratio and just multiply all of your stuff using a proportional relationship and apply these same concepts? Or does the forces not fit that? I'm curious too, because again, physics may be more of his area over there, but what do you think? Somebody tries to apply your same idea to a much larger scale.
I think they'd have very different results.
Okay.
I think there'd be a lot more factors with greater size, like you'd have to consider wind more and all those sorts of things.
Sure. Yeah.
Yes.
If you had any more ability to do testing on it, are there any specific tests that you had, researched that you wanted to do but didn't have the equipment necessarily for?
I didn't really look into it a whole lot, but I think it would have been helpful to be able to like make sure that my math calculations were a little bit more within the ballpark through a more technical solution.
So maybe like researching what other ways you could do.
Yeah.
Would test that.
I I guess one of the things I was thinking is like, okay, this tensile strength, compressive strength, those are significant numbers, and I think you'd be solid. But yet you had the experience of standing on it and recognizing the give that a soft wood like pine has, right? So did that lead to a conclusion about any specific conclusions about how to enhance the design of the bridge? Or how did that even correlate to like, hey, this thing's supposed to hold 32,000 or 23,000 pounds. Why am I? Yeah, it's just gonna hold me, but I'm not sure I'm gonna like this give in the middle of the bridge.
Why am I gonna use this as a trampoline?
Yeah.
Well, I'm just curious what kind of conclusions you drew from that experience.
Yeah, I was kind of wondering about that. So I figured that maybe a little bit has to do with the fact that on the curved parts, like you're not, when your weight is on it, it's not completely straight down. So there's a little bit more physics at play that might be.
How wide across is the bridge?
It's really only like 2 feet, I think.
Okay.
Well, that's good.
I would say one thing you may consider just in observing other designs. Do you know how wide any hall is in your house? One of the first things, okay, just my background, I'm a software engineer now, but I went to school for a year and a half as an architectural engineer. And one of the things you learn in human factors of design is why there are things called regulations and codes. And most halls and doorways have a minimum of like 3 feet wide, because you want to have enough space for a person to safely pass through, or even a wheelchair pass through on a way through a building like that. So only 2 feet wide on a bridge is maybe a little bit narrow. So if that bridge needed to be another foot or two wide to support, a wheelchair access across your bridge, would it suffice? Just more things to consider as you explore the design in general, and how you might solve this problem again in the future, or similar problems in the future.
I know that if you just like would increase the length of those 3 beams, it probably wouldn't hold. But in a number of bridge like models that I looked at, they had a third one in between that would add a whole lot of strength.
And I'm thinking too about your force strengths. That's of the wood itself, right?
Yes.
I mean, I'm thinking of too of like the part of the bridge give is probably not in the wood, but in the connections between the wood.
Yeah.
Right? So like, what's that strength? Because like, if that's my thing, is like, if you just like a piece of wood and you're just pulling on it, that's a lot of weight. But like, if you just, really it comes down to the screw that's connecting those two pieces. That's kind of your force. So I'd wonder like, what could we do to strengthen that? Like,
What's your limiting factor here?
yeah.
To that, the only other part with wood, so I haven't really worked with wood, plastics, metals mostly, but you might see different strengths in different directions because of the grain too. So that would be another one to delve into.
I can speak to that. These numbers he has here are parallel to the grain, which would be the maximum strength they have there. Anything perpendicular is trash very quickly when it comes to tensile strength. It'll split right in half, right?
Pine is this is now just talking from experience and not any mathematical evaluation. Pine, when it gives, it doesn't like snap. It kind of is like just slow over time, because it's very soft wood.
Yeah.
So, in fact, it's great to correlate fun stories from life to things like that. So when I was at college, we built a loft so we could loft our bed. A very classic thing for students to do in college. We used pine, and
Poor college kids.
Yeah, poor college kids. It was the right price point for us, but the soft wood we had to reinforce in multiple ways, because it just wanted to bow and bow and bow, and pretty soon it was just gonna crap out on us. It was a snap, and we realized it. So we had to do extra reinforcing at seams, including like braces across, where we didn't have a board length long enough, or something like that. So your strengths and materials, that's going to be and the way that it's just not like you were saying, not just the wood, it's all the fasteners you use and what kind of fasteners. If you're just using wood screws or you're using lag bolts and other things in your construction.
First bolts for that matter.
Yep,
Joint is always the weak point.
always. I really liked your presentation. I like the humor that you added. That's so necessary in engineering is to carry that personality through. So very nice job. I also applaud you for knowing your customer. When mom's saying, well, I'm sorry, but oak's not gonna be in the price point. It's like, okay, I think that's a great idea, Mr. Customer.
Yeah.
But I will encourage you on the other side too. Your customer is not always right. All right, the customer likes to believe they're always right, but in my experience, the customer is almost always wrong. They don't know what they don't know, and they count on you to know what they don't know. So it's a thing you'll grow into, but don't ever hide behind the customer. You know, be confident in your knowledge and your skill and what you're aware of in solving those problems.
Thank you. Any other panelists that didn't get a?
Kind of piggybacking off that in a little bit of a different direction, though, you did throughout the process, talk about the cost of it. And one thing I've heard, and I know I'm still working on, is a good engineer can talk with the numbers and the work, how you did it, but a great engineer can talk with dollars, because every single engineering project you're working on, generally in some way, is going back to a business aspect. So whether it be quality, whether it be manufacturing cost or something, keeping that in mind is very important. So that was very good.
Thank you.
I want to piggyback off of what Mr. Member here said. Knowing your customer is massively important, especially in engineering. As engineers, we want to fix the problem and we want to fix it so that it's fixed. And that's not always the most cost-effective way to do things, because if we had our way, things wouldn't break.
Right.
But that's not always the most cost-effective way to do it. So knowing your customer is actually one of the first note I had is extremely important. I actually have a question about your math here.
Yeah.
My question is this just the force numbers and compressive and tensile strength for your, I'm going to call them main load-bearing members, which would be your vertical pieces?
Yes.
Or did you take into account the forces on the individual stringers, the planks across as well?
Well, with the limited physics that I am able to do, this is just for the planks across.
All right. Awesome. And then the last question I have is, in doing this, did you find anything, because again, this is one of those great, well, engineers, we can sit in an office and we can design the thing. The execution of the thing sometimes is very different. So my question is, in going through the plan and then doing the execution, did you find anything that really surprised you when you're like, wait a second, I planned this out this way and it's not working. I've got to pivot and change.
Oh yeah. With assembling the wood, when I tried to connect these, I found out that they weren't exactly completely even. So we had to do a little bit of extra cutting to make sure that they were all even and that these would be completely flat and parallel.
You're talking about the round kind of pieces on the side that like flush with the ground, is what you're talking about? The arch parts, yeah.
Yeah, and also the three beams in between, they were a bit like one side was angled, so then it wouldn't be completely flat. So I had to cut a little bit off each side.
Is there any reason why you put them on the way you did with how they're rotated? I'm noticing, like, is that just kind of like with the flow of the bridge, going, like I'm looking at that bottom right quadrant, you got them kind of like rotated differently?
Kind of.
Is that like a purpose, or I'm just curious if just like as you go up the bridge, it kind of rotates with the bridge? Is that what's happening?
They were kind of also to be vertical.
Are you talking about his three beams?
Yeah, the three beams across.
The handrail parts, yeah.
Well, the middle one was put sideways for like ease of attaching it. So
Okay.
that way I could put it in the direct center.
Sure.
So that way, others I'd have to do it off center off the middle beam seems to be stuck in the way.
Got it. Anybody else have anything?
As a general thought moving forward, on top of all they said, you want this pine bridge to exist in a recognizable form in a year after winter. You need to make sure you get that thing finished, lacquered minimum of some sort of like outdoor polyurethane or something like that, or else I guarantee this will be not looking very good and feeling you worse. You step on it, you go like, oh, I'm 6 inches lower than I was in the spring.
Yeah.
So bear that in mind, practically speaking, we wouldn't want this to go to waste like that.
And speaking as a professional woodworker from my last job, you do not want exposed wood, even if it is lacquered and finished, touching the ground. So I would encourage you to find something to put as a barrier between the wood, the exposed grain that you have, and the ground. Because if you can lacquer it up, you can do it all up nice and pretty, but 2 or 3 years down the line, you will rot out wherever the ground is touching your wood bridge.
Oh, go ahead.
Out of curiosity, do you have it, or I don't know if like because this isn't like the permanent solution you mentioned, would you have connected it to the actual concrete somehow, or like is it just sitting on top so you have to worry about movement over time, or like is it shifted?
It's mostly just sitting on top.
Well, you said mobility is important for the sump pump's sake, right?
Yeah,
True.
So-
okay.
Oh, yeah.
we could probably just maybe put some cinder blocks underneath, so that would give it a little bit of lift off.
Better than soil.
Or if you put a layer of rubber or
I was
something.
just gonna
around
say
the
something
bottom,
synthetic
yeah,
underneath it.
Some kind of synthetic rubber on the.
And you could even develop like a nice little landscape plan to go with it, to beautify the rest of the area. If you know your clients and your customers, you gotta keep this customer. The other thing that's beautiful about that is customers then you've got like repeat business, right? It's like, you know what, this will get you through this tough patch, but I got some ideas about how we can enhance this down the road.
For a low fee, you can easily upgrade the situation for you.
I got a guy, he's really good, no, that's not
Buy me a car.